In this lesson, we will examine two common myths about data sufficiency questions that sometimes get students into trouble. The first myth is related to a very common tip for data sufficiency questions. That tip is, do not overcalculate. So if we get a question that looks like this, where we want to find the value of x, we won't waste valuable time solving for x. Instead, we should recognize at a glance that we could solve this equation for x, in which case we could answer the target question. Since we could answer the target question, the statement must be sufficient. Now, this is a useful tip. The danger is that it is sometimes expanded into the myth that suggests all simple equations with one variable can be solved for x. Now, by simple equations, I am referring to equations where the variables are not raised to powers greater than 1. For example, I will say that the equation in this question is a simple equation. Now, can we tell at a glance that this equation can be solved for x? Well, if we obey the myth that says we could solve this equation for x, then we will get ourselves into trouble, because this will lead us to believe that the statement is sufficient. However, notice what happens when we solve this equation for x. First, we'll expand both sides, then we'll simplify both sides. At this point, the equation already looks problematic. When we subtract 3x and add 8 to both sides, we get 0 equals 0. So now that the variables have simply disappeared, what exactly is the value of x here? Well, for this equation, x can equal any number. As such, statement 1 is not sufficient. So, as you have seen, it is not always the case that all simple equations with one variable can be solved for x. Now here's another myth to watch out for. This myth says that all quadratic equations have two solutions. Like the last myth, this myth is partially true. For example, in this question, we want to find the value of x, and statement 1 provides us with a quadratic equation involving x. We can solve this equation for x by first factoring the left-hand side, and when we do this, we can see that x equals 2 or 3. Since there are two possible values for x, we know that statement 1 is not sufficient. The danger here is that these results are sometimes expanded into the myth that suggests all quadratic equations have two solutions. So if we get a similar question with a similar quadratic equation, we might decide to save time and skip the calculations, assuming that this equation will also yield two solutions, in which case the statement is not sufficient. Now this would be a mistake. When we solve this equation by factoring the left-hand side, we can see that there is only one solution to this equation, x equals 3. As such, statement 1 is sufficient. So in this lesson, we examine two common myths. The first myth is that simple equations with one variable can be solved for x. This is not necessarily the case. Before you assume that a simple equation can be solved, you must make sure that this is not one of those equations where the variables disappear. The second myth is that all quadratic equations have two different solutions. This is not always true. So you must make sure that the equation doesn't have just one solution.